Dear students, in this video I explain problems on Nyquist plot or Nyquist criterion. So consider the example for a certain control system g of s into h of s is equal to k by s into s plus 2 into s plus 10. Sketch the Nyquist plot and hence calculate the range of value of k for the system stability. So this is the given problem. Now I want to draw the Nyquist plot for this function and calculate the value of k for the system stability. So first step, if you want to find out the stability of the given system or the Nyquist plot, we want to find out the poles on the right half of the S-plane. So here three poles will be there, s is equal to 0, s is equal to minus 2, s is equal to minus 10. But three poles are, so one is on origin, second one is minus 2 unit distance in negative real axis, second one minus 10 units distance in negative real axis, so that there is no pole on right half of the imaginary axis, so that p value is 0. So step 1, we want to find out step 1, that is calculation of p, where p is nothing but number of poles on right half of the imaginary axis. So from the given problem, there is no pole on right half of the imaginary axis. Total 3 poles will be there. The 3 poles, one is on origin, remaining 2 poles are left half of the imaginary axis, so that p value is 0. So now if the system wants to be stable, that means the formula is n is equal to minus phi. That means the critical point minus 1 plus j0 should not get encircled by the Nyquist plot. So our Nyquist plot should not encircle the critical point, then only the given system is stable. Why? Because p value is 0. The formula is n is equal to minus p, that is equal to 0. That means that critical point minus 1 plus j0 not encircled by the Nyquist plot. So now we will see either the given, after completion of the polar plot, it will be encircled by the critical point minus 1 plus j0 or not encircled by the j0 critical point. So next step 3, now we want to draw the Nyquist path. So this is the Nyquist path. So the pole, one pole is there at origin, so that this is one pole. So the Nyquist path or Nyquist area on imaginary axis and right half of the imaginary axis with radius of infinity. So started here and traveling along with the imaginary axis, but here one pole is there at origin, so that it will bend to the right half of the imaginary axis, and again so traveling on the imaginary axis too up to minus j infinity. After minus j infinity, again it will be reaches to the plus j infinity with radius of infinity. So here some disturbances is there, so that the total area can be divided into the sections. So this is the first section, so that is starting is j infinity, ending is j of 0, plus j of 0. And second section, starting is plus j of 0, ending is minus j of 0. Next third section, starting is minus j0, ending is minus j infinity. Next fourth section, starting is minus j infinity and ending is plus j infinity. So total 4 parts will be there, or 4 sections will be there. Section 1, section 2, section 3, section 4. So step 3 completed. Next is step 4. The given function g of s in g of j omega and h of j omega is nothing but k by, this is the function. So replace s as j omega and calculate the magnitude and phase angles. Why? Because so Nyquist plot is nothing but combination of polar plots. If you draw the polar plot, magnitude and phase both are required, so that calculating the magnitude and phase formulas. So this is the magnitude formula and this is the phase formula. Now section 1, section 2, section 3 and section 4 polar plots are required. Combining of all these polar plots, we can get the Nyquist plot. So section 1. So starting is s is equal to plus j infinity and ending is s is equal to plus j of 0. That means starting in frequency is infinity for this section, ending frequency is 0, so that plus 0. So starting point omega is nothing but infinity. Substitute infinity in magnitude and phase formulas, we can get 0 at an angle of minus 270 degrees, and terminating point, that is ending frequency for the section 1 is plus 0. Substitute plus 0. The magnitude and phase angles are infinity at an angle of minus 90. This is the wrong one. So this is the right one. Infinity at an angle of minus 90. So eliminate this one. This is the wrong one. So infinity at an angle of minus 90 degrees. So now calculating the angle of rotation, that is final angle minus initial angle, minus 90 minus of minus 270, that is plus 180 degrees anti-clockwise rotation. This is the section 1 polar plot. Section 2 polar plot. Starting point is J0, ending point is minus J0. So that the starting frequency is plus 0, ending frequency is minus 0. So substitute plus 0 in magnitude and phase, we can get magnitude as infinity and phase as minus 90 degrees. And substitute omega is equal to minus 0, magnitude is infinity same, but angle is plus 90 degrees. So angle of rotation is plus 90 degrees minus of minus 90, that is equal to plus 180 degrees. So this is section 2 polar, starting and ending points and polar graph. So section 3 is the mirror image of real axis, so that no need to calculate the section 3. Why? Because so this is the section 3. This is the section 3. So that the half. So this is the mirror image of about the real axis. So above the real axis and below the real axis both are same. So that if you find out half, automatically we can draw the next half. So that mirror image of this one. So no need to calculate the section 3. And section 4 is not calculated. Already in given section, last section is not required to calculate. So that section 4 is an origin, no need to calculate the final section or last section, that is 4. So sections are completed, starting and ending points are completed. So now all polar parts are arranged. Finally we can combine all these things, we can get the Nyquist plot. So I say number of times Nyquist plot is nothing but combination of polar plots or adding of polar plots. Step 5. G of j omega into h of j omega is equal to k by this function. So if you want to know where the Nyquist plot is intersecting with negative real axis, so that point is required by calculating rationalization of g of j omega into h of j omega. So therefore rationalization of this function, that means, so this is the rationalization k by j omega into minus j omega, 10 plus j omega into 10 minus j omega, 2 plus j omega into 2 minus j omega. So numerator and denominator both are multiplying with minus j omega, 10 minus j omega, 2 minus j omega. So after multiplying these things, so we can get like this the function where d is equal to this one. So equating the imaginary parts to 0, therefore, so after equating the imaginary parts to 0, omega into 20 minus omega square is equal to 0, therefore omega square is equal to 20, therefore omega pc, so phase crossover frequency omega pc is equal to root 20. And substituting in real part, so where point q is equal to, so substituting this thing, so therefore minus 12k by 20 divided by 20 into 20 plus 4 into 100 plus 20, that is equal to minus k by 240. So this is the point q. So this point is on negative real axis. Therefore, so rationalization completed. So finally the polar plot intersecting with the negative real axis at minus k by 240 point. So finally we can draw the Nyquist plot. So this is the Nyquist plot for section 1, section 2, section 3 and 4. So that means section 1 starting and ending. So starting and ending section 1. So this is the section 1. Section 1. So 0 at an angle of 270 degrees. So at minus 270 degrees line 0 magnitude and minus 90 degrees line infinity magnitude. So first point is 0 at an angle of minus 270. So minus 270 means this line, minus 270 line. So 0 means this one. So here this is the first point. So 0 magnitude and angle minus 270 degrees. So that this is the first point. And so next point. Second point is this one, infinity at an angle of minus 90 degrees. So on minus 90 degrees line, magnitude is infinity. So on minus 90 degrees, so this is minus 90 degrees line, so infinity magnitude. So for example, this point is as infinity, so that look at this point. So starting point is this one, ending point is this one. Now angle of rotation is required. So for part 1, the angle of rotation is, so this is the part 1, the angle of rotation is plus 180 degrees, so that it will covers 180 degrees in, so anti-clockwise direction. Plus means anti-clockwise direction, so that it starts here and traveling like this. So that means only 90 degrees covered, and after traveling like this, it will be covered 180 degrees from here to here 90 degrees, and here to here 90 degrees, total 180 degrees in anti-clockwise direction completed. So the polar plot for, so section 1 is like this one. Next one, the polar plot for section 2 is this one. Starting point is J0, so ending point is minus J0, so that, so from here to here, so again rotation. So this one, part 2, so starting frequency is, so for starting point, magnitude is infinity, angle minus 90 degrees. So infinity at an angle of minus 90, infinity at an angle of plus 90, so that, so infinity at an angle of minus 90 degrees this one, plus 90 degrees this one, so infinity distance. So this is the infinity point and this is the infinity point, so the starting point here and ending point here, and angle of rotation is plus 180 degrees. So again it will be covered plus 180 degrees in anti-clockwise direction, so that from here to here 90 degrees and here to here 90 degrees. So that starting point is this one, ending point is this one. So starting here and covered 180 degrees, it will be reaches to the final point. So section 2 completed. So section 3 is mirror image of section 2, so that exactly mirror image of this one is nothing but starting here and cover like this and reach to this point. So this is the total Nyquist plot. So combining of all polar plots are nothing but Nyquist plot, and this point is nothing but k minus k by 240. So this is the polar plot. So the Nyquist plot intersecting with the negative real axis point is nothing but q. This q is nothing but minus k by 240. So the given, if the given system is stable, so this minus 1 plus j0 not encircled by this polar plot, so that the point, so finally we can calculate the k value when the system is stable or when the system is unstable. So if this position, then only the n value is 0. If this minus 1 plus j0 here, it will be encircled. So that now the situation is the polar plot, so the Nyquist plot cannot encircle this point. So even single time is not encircled minus 1 plus j0. That means n value is 0. So p value is 0, n value is 0, then only the system is stable. So this is the required condition, the given system is stable. So now we want to calculate the k value for given system is stable. Now for the absolute stability, n is equal to 0. That means critical point not encircled by the Nyquist plot, so that it should be located on the left half of the, or left side of the point q. Therefore the distance between OQ is less than 1. So that means the distance between OQ is nothing but, this is the O point, origin point, this is the Q point. The distance between these two is less than 1, then only it will be stable, otherwise it will unstable. Therefore the distance between these 2 points is minus k by 240 is less than 1, therefore k is less than 240, so that the range of value of k for the system stability is 0 less than k less than 240. This is the condition for the system stability. So this is the Nyquist plot for a given system or given problem, and calculation of the given system is either stable or unstable. So up to now the 4th unit was complete.